All right, guys, need your review sheet out. We're going over it today. We're going over the review sheet today. So, we're going to go on and get started with this here. So, the first problems we're going to look over are problems 1 through 5. Describe the transformation of each quadratic function. Now, there's going to be 4 main types of transformations that are going to occur or we're going to see. Horizontal translation, we're moving it up or down. Vertical translation, moving it left or right. Vertical stretch, vertical shrink, and reflection across the X. Horizontal stretch and shrink and reflection across the Y are not going to show up. Those will not be a possible option. They're not going to be on the test. So, any questions on 1 through 5 or any of one of these in particular y'all want to look at? If not, I'm going to look at 4 in particular. Now, 4 has 4 transformations. We have the -4 outside the parentheses, the +3 inside. We have the negative and the 6, because the negative and 6 have 2 different transformations. The negative in front of the 6 tells us that there is a reflection across the x-axis. Because if there's a negative where A is supposed to be, the negative is part of the reflection, the number isn't part of the vertical stretch or shrink. And since there is a number in front of that parentheses, we'll have vertical. If that number is greater than 1, it's a stretch. And this here, since 6 is greater than 1, it would be a vertical stretch of 6. If that number is between 0 and 1, it's a vertical shrink. Questions on the vertical stretch and the reflection across the x-axis. Now we have the +3 inside. The 3 inside tells us that we're moving to the left or right. Inside the parentheses is the opposite of what we think. So since it's +3, it would be left 3. And the -4 outside the parentheses, our value of k moves it up or down. And our up and down is exactly what it looks like, so that would be down 4. So number 4 would be a reflection across the x-axis. Vertical shrink of vertical stretch of 6, left 3, down 4. Questions on this here? We feel good with number 4. We can also look at number 5. Look at 2 of these here. Number 5, just like number 4, has 4 transformations. Now, not everyone on the test, all the transformations on the test will have 4. Most of them will probably just have 2 transformations. But this one has 4 because we have the negative and our 0.7 +4 -1. The negative is telling us that we have a reflection across the x-axis. The 0.7 in front of it does tell us that we have a vertical stretch or shrink. It would be a vertical shrink because 0.7 is indeed between 0 and 1. The +4 inside the parentheses is our left and right, and it is the opposite of what we think. So this is left 4. And our -1 tells us that we're moving it down 1. Any other questions or any questions on 1 through 5? Now, if you want to see the other 3, I do have a full review video that's going through every problem. I worked through all of them. It is already up on YouTube. So if you want to go back and look at 1 through 3 or see 1 through 3 and kind of an explanation of it, not a whole lot, but it is up there. Let's look at 6 through 9. 6 and 7, we want to find the vertex and the axis of symmetry. Is there one of those in particular that y'all want to look at or have questions on? With 6 and 7. Okay. We're going to do one of them. That way, it gives you the opportunity to do one of them at home if you weren't here yesterday to do it. We can do 7. Now, again, the back of the review sheet does have all the formulas. And if you want, it might be helpful, especially for vertex form, because we're looking at the one in the middle. Set of formulas, vertex form, y equals, or f of x equals, either one, a times x minus h squared plus k. Since it's just asking for the vertex and the axis of symmetry, we're looking at those middle three. It might be smart, or if you find it helpful, to put 6 and 7 next to it as a reminder. These are the type of problems we're looking at, the formula. Here, vertex is what we're trying to find, which is a point, and the axis of symmetry. And for these here, for 6 and 7, the only axis of symmetry we have is x equals. We won't have y equals for axis of symmetry for these two here. Now again, axis of symmetry, we do need the equation x equals because there are points attached to putting x equals. Now the general form, if we look at the back for the vertex, is h comma k. Axis of symmetry for this, x is equal to h. So to find the vertex and the axis of symmetry, we just need the values of h and k. Well, from the equation, k is added to the outside. Since there is no number there, k is 0. H comes from inside the parentheses, and it would be 1. But because it's plus 1 inside the parentheses, it comes out as negative 1. So our vertex is h comma k, which would be negative 1, 0. Axis of symmetry would be x equals h, so x equals negative 1. And that is it. So again, I would keep referring back to those general forms to determine what we need. Questions on number 7? Okay. If we feel good with 7, we'll look at number 8. I'm going to do number 8 because it looks a little bit harder than number 9. Now, number 8 is standard form. 8 and 9 are both standard form. So on the back, it is the middle equation. It's our ax squared plus bx plus c. So doing this here, it's going to be helpful to know what is the value of a, b, and c. A is going to be the number in front of x squared, which in our case is negative 1/9. The number in front of x is our b, 2/5, and c is our number without a variable, negative 3. The values of a, b, and c will not have a variable because it's ax squared. A is the number in front of x squared, bx. B is the number in front of x, and c is the number by itself. Vertex is still a point, and in the general form, it's negative b over 2a comma f of negative b over 2a. And our axis of symmetry, x is equal to negative b over 2a. So the key in solving this here is finding the value of negative b over 2a. Scroll back up. Negative b over 2a. So if we look back to our ABC, well, negative b, negative. Our b value is 2/5. 2 times a, well, a is negative 1/9. I'm plugging the value of b and a back into that formula, the negative b over 2a. At this point here, we can just plug that into the calculator. Negative, well, clear that out. Fraction negative. Our b is 2/5 over 2 parentheses fraction negative 1/9. I'm just going to type that in exactly how it looks when we plug the values in. So negative our b value over 2 times our a value. Hit enter, let it calculate it for us, and it tells us it's 9/5. So our b, negative b over 2a is 9/5, which means the x value of the vertex, first value of the vertex is 9/5. The axis of symmetry is x is equal to 9/5. Now the only thing we have left to do is to find the f of negative b over 2a. All that means is take that value we found, 9/5, and plug it back in the equation for x. So we would have negative 1/9 times 9/5 squared plus 2/5 times 9/5 minus 3. One more time. Yes. And again, I wouldn't try to, sorry, I just plug the whole thing exactly as it looks. Let the calculator do all of the calculations for you on this one here. Negative 66 over 25. Questions on our 7 and 8? We feel good with these here so far. Okay. 11 through 15, we want to find the vertex, or not the vertex, the focus, axis of symmetry, and the directrix. It doesn't ask for the vertex. You can give the vertex if you want, but it's not going to count for you or against you because it's not asking for it. There's a reason for it. Because for all of these here, 11 through 15, the value of the vertex is going to be 0, 0. There is no h and k value. Looking through 11 through 15, is there one of those in particular that y'all want to look at? Or had questions? Number 15. This one here. Oh. 11 through 15. Okay. So does anybody have any one of 11 through 15 in particular that y'all want to see done or worked? 14. Number 14. 8x squared equals y. Well, this would be the same as what? Those are the same thing. Just because it's on the left does not make it a different problem. But we have this here, and again, with any of these here, going from the equation to the vertex, directrix, axis of symmetry, and focus, even though we're not finding the vertex here, doesn't make a difference. Or going from the given information, vertex, directrix, vertex, focus to the equation, we want to match it up to the general form. So again, I'd be looking at that reference sheet every single time when looking at this here. Because here it gives us y equals 8x squared. Well, the general form is y equals a times x minus h squared plus k. That's the general form. I just took it straight from there. Yes? Huh? Yep, h and k are 0. Because here, since there's no parentheses and nothing added to the end, h is 0. K is 0. That's why I said the vertex is 0, 0. And a is indeed 8. Now, for all this here, for when we're finding the focus, directrix, and axis of symmetry, we don't need a, we need p. In p, again, straight from the back, p is 1 over 4a, 1 over 4 times 8. Again, we can just plug that 1 over 4 times 8 in the calculator, and it'll tell us it's 1 over 32. Again, looking at the back, so we're going for focus, directrix, axis of symmetry. In the general form for y equals, focus is h comma k plus p, directrix, y equals k minus p. Axis of symmetry, x is equal to h. Well, our h value is 0. So h comma k plus p would be 0 comma whatever k plus p is. So we can do that. We'll do that calculation here in a second. Then we also need to find k minus p. And our h value is 0. So our axis of symmetry would be x equals 0. So the only other things that we have to find or solve for is k plus p and k minus p. So we'll start with k plus p. I plug the value of k in, which is 0, plus our p value is 1 over 32. So 1 plus 1 over 32 is 1 over 32. So our focus is 0 comma 1 over 32. Our other one we need to find is the directrix k minus p, which would be 0 minus 1 over 32, which is negative 1 over 32. Directrix and axis of symmetry, I do need the x equals or y equals. That is part of the equation, and I do give points for putting that. So even if you don't get the k plus p or k minus p, you can still get points for having it set up correctly. Questions on 14? We feel good about 14. Is there another one of those that y'all want to look at? Which one? 13. Y equals a x minus h squared plus k. No parentheses, so h is 0. Nothing added to the end, so k is 0. And our a here would be negative 1 over 48. But we don't need the a value for our focus, directrix, or axis of symmetry. We need the value of p. Well, p is 1 over 4a, so 1 over 4 times negative 1 over 48. And again, I'm just going to let the calculator do that for us. And it tells us the value of p is negative 12. Focus. Directrix. Axis of symmetry. Again, at this point, I'd just be looking at the reference sheet for y equals focus is the point h comma k plus p. Directrix, y equals k minus p. Axis of symmetry, x is equal to h. And even though we haven't done our equation for anything, even if I didn't find h and k yet, I can still get the x equals y equals just based off the equation. With h and k, focus would be 0 comma whatever k plus p is. Axis of symmetry, x equals h, so x equals 0. Now our k plus p, we can find it next. So k plus p would be 0 plus negative 12. And 0 plus negative 12 would just be negative 12. Our other one is going to be k minus p, which would be 0 minus negative 12. But our negative here would make a positive, giving us positive 12. And that's it for those there. Questions on these here, or anything we've done so far? Hopefully notice so far everything that we're doing in this chapter has a big focus on the general forms. Keep matching them back to the general forms. Find A, H, and K, find these values that we need and plug them in. (16) through 19, is there one of these that y'all want to look at? Any of them? Okay. We'll look at 17. Now on the test, they'll look a little different. I'm not going to give you the vertex. I'm not going to say the vertex is 0, 0 on each one. It'll say it in the instructions. Also, another giveaway, if you're just given the focus or directrix, nothing else, most likely it's going to be this here. Also, if it's the focus, one of them is going to be 0. Now, if we look at this here, vertex, HK, H is 0, K is 0. That's just the vertex. And on the test, it will say that the vertex is 0, 0 in the instructions. Now, the focus, we have one of two equations. It's either H, comma, K plus P, or H plus P, comma, K. Which one of the values changed from the vertex, or which one actually has a value for this one? Yeah, because our K plus P has a value. That's the one that changed, which means our H plus P, comma, K is not it. Which is nice because now I can go back to the general forms. And we do know what P is. And see which one of the two equations had H, comma, K plus P. Well, that's our Y equals A times X minus H squared plus K. It also tells us, because we need to find P in order to find A, that our K plus P is -7. K was told to us to be 0, so 0 plus P is -7. Well, 0 plus P, 0 plus anything is whatever the other thing is. So we have P equals -7. Since it is positive, our value of P is -7. Now, as tempting as it is to just plug -7 in for A, we can't, because to find A, the number we plug in, we got to do 1 over 4 times P, 1 over 4 times that number. And again, we can just grab the calculator. 1 over 4 parentheses -7 is -1/28. So our value of A is -1/28. Which tells us our equation is Y is equal to, we plug in our value of A, -1/28, times X minus 0 squared plus 0. If you leave that as your final answer, that is correct, because that is the correct answer. But we can also simplify the zeros. And it simplifies down to Y equals -1 over 28 times X squared. And I've seen it, not a whole lot, but I've seen it a few times. Do make sure that exponent looks like an exponent. Just make sure it doesn't look like X times 2. So just make sure that does sit up there as an exponent, okay? Questions on this here? And again, as I've been saying this entire time, I would keep referring back to those general forms each time. Line them up. Where's A, H, and K? We feel good with 17. If we don't have one in particular, we'll look at 19. 19 is a little different because it didn't give us the focus, it gave us the directrix. Directrix is kind of nice because there's only 2 of them. It's either X is equal to H minus P, or the other one is Y is equal to K minus P. is going to be h minus p because we have x equals. If it was y equals, it'd be the other one. Now, since it is x equals h minus p, if we look back at the general form, it's x equals a times y minus k squared plus h. Again, I'm just matching them up back to the general form. And vertex, we hadn't listed it yet. Since the vertex is 0, 0, the value of h and k are 0 and 0. Now, the only thing we need or have to find left, or what we're needing, is the value of a. But to find a, we need to find p. Now, it's told to us from the directrix that h minus p is negative 9. Well, the equation is x equals h minus p. They gave us x equals negative 9. So h minus p has to be negative 9. H was told to us to be 0. Well, 0 minus p is negative p. Now here we do need to simplify. We're going to divide by negative 1 because I want to know what the value of positive p is, not negative p. And negative 9 divided by negative 1 is positive 9. Last but not least, to find a, 1 over 4 times p, 1 over 4 times 9. And if we plug this into the calculator, we get 1 over 36. Telling us that x is equal to 1 over 36 times y minus 0 squared plus 0. On the x equals equations, do be careful to not switch your h and k, because k for this one here is inside, h is outside. But for this one here, it's kind of nice because h and k are both 0. So even if we did flip it, it gives us the same equation. And if we wanted to simplify, we can say x is equal to 1 over 36 y squared. Questions on 16 through 19? Again, I do have the full video up that has all the rest of them, so if you didn't get time to finish the others, you can go back to those and check them if you have questions. Email me also if you do have questions. 20 through 23, find the vertex, focus, axis of symmetry, and directrix. Here we're finding all 4. Any one of these in particular, any one of these 4 that y'all want to look at? 21? So 21, x equals 4 times y plus 5 squared minus 1. In the general form, x is equal to a times y minus k squared plus h. The 3 things we can get from the equation are a, h, and k. Then we can use a to find p. Here, h is on the outside, and when it's outside those parentheses, it's exactly what it looks like. So h is negative 1. Minus 1, h is negative 1. K is inside the parentheses. So it's matching up with our plus 5. Now, since it's inside the parentheses, the sign's going to switch. Plus 5 inside comes back out as negative 5. And our value of a is 4. I don't really care so much about the value of a, because to find the vertex, focus, directrix, and axis of symmetry, we need the value of p. Well, p is just 1 over 4a. 1 over 4 times 4, which is 1/16. Questions on how we found p, h, and k? Now at this point here, again, I just go back to the general forms. Vertex, and the general form is h comma k, which for us here would be negative 1 comma negative 5. Focus, for us here, x equals is h plus p comma k. Haven't calculated h plus p yet, but I can still just plug in the value of k, which is negative 5. Directrix. The general form is y is not y equals, is x equals h minus p and again, not quite. Yeah, sounds good. So direct 6, and I like the fact that I did that because, again, as you saw, it's easy to switch these up. That's why I keep referring back to the general form. X equals h minus p. We haven't calculated that, but that's fine. Axis of symmetry, y equals k. Well, k is -5. Yeah. Now, even if you don't get the rest of it, you have essentially 80% of this problem done, because the only thing we're missing is h plus p, h minus p. H plus p we can do first. H plus p would be -1 plus 1/16. Just grab a calculator, let it do it for you. -15/16. And h minus p, -1 minus 1/16. Again, -1 minus 1/16 is -17/16. So even if you miss the values for p and get the rest of it, you are getting 80% of this problem. It's not all or nothing. Questions on this here? Okay. All right. I'm just going to pick this one here. This one here is y equals, not x equals. So we have y equals a times x minus h squared plus k. Our a is 1/16. H, since it's -3, it comes out as +3. Comes out of the parentheses as +3, and our k value is 1. Now we don't care so much for the value of a. We need it, but to find our answers, we have to do 1/4a. 1/4 times 1/16. And again, we can do that in the calculator. Not that. 16th is 4, so our value of p is 4. Vertex is our point h comma k. H is 3, k is 1. Focus is our h comma k plus p. Don't have k plus p yet, but we can still fill in the value of h. Direct 6, y is equal to k minus p. Don't have it yet, but that's fine. Axis of symmetry, x is equal to h. So just with h and k, we have 80% of this. We're just missing the two parts. And the two parts that we're missing are k plus p and k minus p. Or k plus p would be 1 plus 4. And 1 plus 4 is 5. K minus p would be 1 minus 4, which is -3. And we plug those into their spots respectively. Questions on finding the vertex, focus, direct 6, and axis of symmetry. We feel good with these here. Again, if you didn't get time to do this, I would go back, do the rest, or do some of the others, and the video will have the full explanation if you do get stuck, or email me. See here. I'll start off with 24. So this time we're trying to find the equation. We need A, H, and K to get the equation. Now, on all these here, on the test, you will be given the vertex or focus and vertex and directrix. Vertex is H and K, so this is telling us H is 7, K is 3. Focus comes in one of two forms, H plus P comma K or H comma K plus P. If we look at the focus from the vertex, vertex is 7, 3, focus is 14, 3. The second value stayed the same. It's just K. Because P should be going whichever one changed. P changed in the first, so P is going to be a part of the first one. And P is indeed going to be 7. So we'd have our H plus P comma K. Now that does help us figure out what P is, but it also tells us which equation. Because if we match it up with our H plus P comma K, the general form is our x equals a times y minus k squared plus h. So we have h and k, we just need to find p. Yep. So really we're trying to figure out which form it is, either h plus p comma k or h comma k plus p, to determine which equation we have. Now since this is h plus p comma k, I'll look back at the general form and see which one has a focus of h plus p comma k. Now if it's the other one, h comma k plus p, it's the other equation because they only attach to one. Does that make sense? Determining? Yeah, and that's it. Now, to find p, we plug in h. 7 plus p equals 14. So here we would subtract 7, telling us p is 7. Yes. So a is going to be 1 over 4 times p. 1 over 4 times 7. And again, 1 over 28. Just plug it in the calculator. Let it do that for you. And now we're just going to replace a with 1 over 28. Y minus k, y minus 3 squared plus 7. Because once we find a, h, and k, just plug them back into the general form, and we have the equation. Questions on this here? All right. I'm going to look at 26 because 26 has a directrix. Directrix is a little bit nicer because there's only 2 of them. Either x equals or y equals. Here we have y equals, so the general form is y is equal to k minus p. Vertex is still hk. H is equal to -6, k is equal to -4. Now because the directrix was y equals k minus p, the general form that has that directrix, that equation for the directrix is our y equals a times x minus h squared plus k. Now at this point, even if we don't get the value of a, we can still plug h and k in. We get x minus -6. Well, the negative makes a plus. Plus -4, that's the same as -4. So we have this here. We just need to find the value of a. But to find a, we've got to find p. Well, our k minus p from the directrix is matching up with our 2, telling us k minus p is 2. And k is -4, so we replace k with its value to solve for p. First thing we would do is add 4 to both sides. minus negative p is equal to 6. We'll divide it by negative 1. Our negative p divided by negative 1 is positive p. And 6 divided by negative 1 is negative 6. Now we need to find a. Well, a is equal to 1 over 4p, telling us a is negative 1 over 24. A does not have to be a fraction. A could be a whole number. Just plug it in, and whatever number you get, plug it in for A. I would not focus too much on what it looks like more. That's the value of A. Questions on 26? '28 is bonus. I did do the bonus on the video, that full video. I'm going to leave it there because, again, we are pressed for time. So if you have time for it, watch it. Again, that's not going to count against you. It's purely bonus. 28 through 33 are not on the test. Those are not on the test. None of those are on the test. The vertex and a point, or the x-intercepts and a point, aren't going to be on the test. The last piece that is going to be on the test is this here. 34 through, or well, really 35 through 37. Is there one of these in particular that y'all want to look at? This here is what we did a part of, not so much 2-4, I think this was 2-2, because this is going to be one of the last equations in the middle, our x-intercept form. 37, yes. Because this is our f of x, or y, is equal to a times x minus p times x minus q. So here, the main thing we need to find is the value of p and the value of q. Now, our p and q come from inside the parentheses, and we do flip the signs. Since the 7/9 is plus, it's going to come out as negative. The 3/4 is negative. It's going to come out as positive. We flip those signs when they come out of the parentheses. Now, it asks for a few things. It asks for the vertex. And in the general form, it's p plus q over 2, comma f of p plus q over 2. Axis of symmetry. X equals p plus q over 2. And this one did ask for one more piece, the x-intercepts, which are going to be 2 points. And that's p comma 0 and q comma 0. Well, just from the form, we do have half of the x-intercepts, because the y values for both of those will be 0. Well, the values of p and q we already have, yes? Plug it in, negative 7/9 and 3/4. The order in which you, question? The order in which we put them doesn't matter. If you put 3/4 comma 0 and negative 7/9 comma 0, you flipped it. Same thing, it's just the 2 points. We just need them listed. So if you flip these, the order in which we list them doesn't matter. P and Q, which one's P, which one's Q, doesn't matter. One of them needs to be P, one of them needs to be Q. One of them needs to be negative 7/9, one of them needs to be 3/4. We need one is P, one is Q. Okay? Now our P plus Q over 2 is really the next thing we need, which would be negative 7/9 plus 3/4 over 2. I just grab a calculator, let it do this. Negative 7/9 plus 3/4 all over 2. And the nice thing with addition, again, Order in which we add two things doesn't matter. So we just add the P and Q and divide by 2. And get negative 1 over 72. And our f of, just like with standard form, all that means for us is plug it back in. So we're just going to plug that entire thing back into the calculator. That might have been in the way of someone. Minus plus 7x. And we get this here. This will not turn back into a decimal. All the ones on the test, especially for all these here, you can turn them all back into fractions. This one's just that not nice of a number. So 0.85835. And for those that are curious, this is actually 3,025 over 5,625. That's part of the reason it really didn't convert it back. Questions on this here? Question, Conley?
That I don't understand, but I don't have a certain question.
So really the main thing with this here is P and Q. Once we find P and Q, we're going back to the general form. Because P plus Q over 2, both of these here, plug in P and Q for it, simplify, will give us this here. We take that, plug it back in place of X to get the other. This here, this one just worked out to be a decimal. I wouldn't convert back, but the ones on the test will go back to being fractional. Now, if there's any of the other part of the review sheet you have questions on, ask. The video does have all of them on there. The only one, if you go back and watch 8, I do it twice because I forgot to change it. Because I changed it here. I fixed that.
Well, I did number 21 like 3 times before I got it right.
Yep. So if you do have questions, ask. But our test, the first half's tomorrow.